All right, so let's talk about error handling in Python today. And this lecture is slightly misplaced because uh, I think I should have ideally done it after the classes because I wanted to show you the custom error handling as well. But what I'm going to do is I'm going to do a later session when I cover classes. I'll just cover that part in that particular module. So let's begin by writing some basic stuff. So what is error handling? We have seen errors in Python, right? So in different forms, we have seen certain errors. Suppose you have a list, and let's say the list is some numbers, and you try to access the list, an element which is outside the list index, then you get an error, right? So this essentially tells Python to terminate the program unless you're handling this particular error. Your program will terminate at that point. So the errors usually follow this pattern where you have something like a name, index error, and then some kind of a description, some kind of a message that, okay, this list index is out of the range. And we have seen other errors as well. For example, suppose you have 1 divide by 0, right? So that is a zero division error. Or let's say you have 1 divided by a. Once again, all of the errors types are different. You have a zero division error, then you have a type error, or suppose you have a dictionary and the dictionary has some keys in it, key values, and suppose you want to access something that is there, then it's fine. But if you try to access something which is not there, then you get a error. So this is a key error. When you will write big programs, these errors will occur and you may have to address those errors. And there is a mechanism to do that. And this is what the session is about, which about error handling in Python, how to do that. And the one important thing to understand is that we don't want to ignore the errors, right? So it's not that we get an error, we don't do anything and we just continue the program. We have to take some action. That's why this is there. So let's understand the error handling mechanism in Python by writing a simple program. I'm going to open the IDE and write the very first simple program to show some error handling. So let's save this. So the mechanism for error handling in Python is called the try except. So you write a keyword called try, put a colon just like any other block, then you hit enter and the indentation begins. Now anything that you do here can have potentially some kind of an error. It can throw some kind of an error, right? You may be able to check it in advance before doing something, or you may not be in a situation to check it in advance. So suppose you do something, right? So you write something risky here. If that generates an error, suppose you try to access a list which is not big in size enough, so then an exception will be thrown. And in Python, it's called an error will be thrown. What will happen is that error will then, the program control will come to the next block, which is except block. So suppose you have statement 1, something risky, then statement 3, and then statement n. Suppose you have something like this. So your program control will come from line 3, it will come to line 4, you will execute this statement, and then something will happen here. If this throws an error, right, then your program will essentially skip the line number 6 and 7 and go directly to the except block. In this except block, you have an opportunity to deal with this error. You can write maybe something like something like this. You can log something, you can write like print something. You can raise the exception again if you want to here, or you can take some corrective actions. Suppose uh, in this particular block, you're going to deal with the error itself. So this is the general format. You can basically raise the exception again by writing this, or you want to discontinue something, you can do that. The full block, the full extent of this is that there is another block which is called finally, where you can do something more. And if you had, let's say, some kind of a files were open or something like that, then basically you can close the connections. You can free up the resources if you want to free up the resources. All of that you can do here in the finally block, right? So suppose this block tries to open a file and does a bunch of work, then essentially you can come to finally and do the uh, closing work. Now let me just go through the flow here real quick of how this works. So the first thing you have is a try block with some stuff. Then you have an except block. Then you have a finally block. So in try, you're going to, as you come here, you're going to try something. And let's say then that there is an error that occurs here. Then the control flow will eventually quickly take you from here to the except block. You will execute all of these lines in except block, and then you will come to the final block, and you will execute everything that's in the finally block. But if let's say there is no error, let's say you come from here, all of this is good, then you will completely skip the except block and you just directly jump to the finally block and do everything you want to do in the finally block. In many situations, you don't need finally block and you can just get around with the try and except. So let's run an example to really understand this. I'm just going to get rid of this. It's not really needed. Suppose I'm defining a function. Okay, suppose this function is called, let's use the example that we saw in the previous terminal window. This is called, let's say, divide. We're going to take two numbers and then we're going to perform the division of those two numbers. Suppose I'm going to write return A by B in the program. And suppose I call divide and I pass 5,1, that's okay. Then I call 5,0 and that's a problem. So when you run this code, you're going to get into trouble. Zero division error comes, say division by 0. Now, this is the risky operation here. So essentially what you can do is we can put this inside the try block and write something like maybe like return A by B here. And then put an except block, and in the except block, do something, say print some error has occurred. So when you now run this, notice that you will do this and then you will write some error has occurred and you'll be printing none because this we're printing this. Your function is not returning anything now. But essentially what you were able to do is you were able to come back from this error. There should have been a better way to deal with this, but at this moment, suppose this is the implementation right now. So you basically got the error and you're accepting this error. Okay, I'm going to move forward in this discussion, but if you want to try this out quickly yourself, just do it, and then I'm going to move forward from here. All right. And if you have any questions still far, you can also ask me. Yeah, so this is a generic exception, right? And You can also do something like, first, let's a little bit more about the generic exception. So you can catch the exception with some kind of a name. So this is the exception name, and then you can uh, exception, and then basically you can as E, if I'm not mistaken, yes. And then essentially you can just say print E. Let's just say print E. And then when you run this again, division by 0. So yeah, let me just really remove this raise. So you can write it like this. You can also get the exception as some kind of a variable, and then basically you can print that error message. It's the division by 0, the error that we get. But let's move forward to some more stuff. So this is a generic exception. We just wrote a except and we just did this. We can catch specific exceptions as well. Okay, so suppose that we know that when you divide by when you divide two numbers, the one number, the denominator, if it's 0, then you have a problem, and that particular error is uh, division by 0, zero division error, something like that. Let's just quickly see the name of it. Zero division error. You can just use this. You can catch specific exception as well by putting as many except block as you want. So you can write this. So you can say, okay, catch zero division error. So, and then you can print this. You can say, okay, print denominator is 0. Right. So now see the message. The message is going to be different. Essentially, you're going to have denominator is 0 because you caught that particular specific exception here in the zero division error. Right. And
specific word zero division error.
Can you repeat the question?
Where did you get the specific word zero division error?
Yeah. So you have, so all the errors have a name, and essentially I can tell you how to look up those names as well. But essentially when you do this operation, I just tried it from here. On the terminal, I said 1 divided by 0, and I got a zero division error. That is the name of the error.
Okay.
Yeah. So if you write, let's say 1 plus A, then you get a type error. So you can use the type error as well. So you come here and you say zero division error, you catch it. The important thing to understand is that you want to go with the most specific on the top to more general at the bottom, right? So basically I'm using the Java term called catching an exception. Essentially, suppose you do some operation and it throws an exception, then the most broad bucket is the general exception. You can call, basically you can catch anything here. But if you want to catch something specific and take action, then you have to put the most specific buckets first. So this is, let's say, zero division exception. And then there is a type error. You want to put those before. So if this exception occurs, then first it will try to see, is this a zero division error? If this is, then okay, fine. If this is not, then is this a type error? If this is, then it's good. Otherwise, let's say you come here and then you look at the generic exception.
This seems to suggest there is a hierarchy of the errors. Is that true?
There's no hierarchy, but I mean, these are more specific forms of errors. So you want to put them first. Otherwise, this is catch all. This is going to catch everything before you reach.
That's right. So catch all should be at the bottom, but does it matter whether I'm mentioning zero division error or type error in any order?
So in that case, it will not matter because these two are very different errors. If you get a zero division error, then it cannot be a type error. If you get a type error, then it cannot be a zero division error. Right. So these two are very different in this case.
Okay, got it.
So let's try this. Okay, suppose I'm going to try this again, and let's just call this with something else. Divide this. So when you run this, let's run, and first error you're gonna get is dividing in 5, that's fine. Then you get denominator is 0, so you reached this error, 0 division error. And in the third one, you say some error has occurred. You can catch this as the exception, generic, and you can assign it to a variable. You can say accept this exception as E, so this is available as name E, and you can just say print E. Okay, let's run this, and you will get the error that is occurring. This here. So this is another type of error that we can get. Now, if we want to catch that error as well, specifically, then basically we can write except. We can get the text again, either from our previous window, or let's just run this again from here. Type error. We can write except type error, and then just print something. Something like here, looks like something other than numbers was used. So it's just some general message. So now when you run this, you got that particular error, essentially. So in that way, you put the more specific errors at the top and more generic errors at the bottom. And these two are unrelated, so they can be in any order right now. Okay, I'm going to give you a minute to try this out yourself, and feel free to discuss if you have any questions.
I mean, what are, fatal errors will not execute the finally block, like, something happened to the server, but is there other specific commands that you can force it to bypass the finally?
I don't know, you cannot bypass the finally.
Okay.
Finally will be entered if it's there. Yeah. So you can also raise exceptions if you're doing something in your code. You can just raise the exceptions as well. So first a quick word on some exceptions. So there's a whole class of exceptions, and I think somebody has posted in the chat as well the list of the exception built-in exceptions. But you can also create your own exceptions. That exception may be custom to your work, whatever you're doing. But in order to do that, we need to look into classes first. And so that part I'm going to cover when we talk about classes later on. So essentially, you'll define some kind of a class, and you will say some, like, my particular type of an exception, which will be a type of exception. And then you will define its various parameters inside the definition of class. So once you do that, you can also throw those exceptions. So from the next lecture, when we talk about modules and we talk about modules and classes, we will start looking in those particular type of exceptions as well. But in your code, you can also raise exception. You can just, whenever you're writing code, if you just want to raise an exception, suppose you say if 4 is, let's say, less than 5, then something like, let's say, raise exception. When you do that, this code will raise an exception. You can raise a specific type of exception. So you can say if 4 is less than 5, then raise, let's say, let's just copy something from here. Let's say 0 division error. It will raise a 0 division error. Now, Python doesn't care in this case. We are customary saying that if this condition meets, then just raise the exception. And in this particular case, Python doesn't really care whether zero division error really occurred or not, but it will throw a zero division error. So when you write a function that is supposed to do something, but it doesn't do, you can always raise exceptions like this. For example, suppose you're writing a function. Okay, let's just write a function, and this is called def func, say a comma b, and let's say suppose this function says return a comma a plus b. Okay, and basically let's just call this func, let's say 5 comma 4, and you can let's just print it. Straightforward stuff. Now what you can do is you can essentially check, right? If let's say type of a is not equals to int, then let's say raise type error. So this is, I mean, I'm just checking the type. I'm just showing you something like this. Or you can write something even more mundane. You can just write if is digit a. So if not is digit a or not is digit b, then raise type error. So let's say you run this code, and then you say, suppose this pass this a, then you're gonna get into an error. Sorry, my mistake. Wait, what? Oh, my mistake. What am I doing?
Strings don't have is.
Yeah. Sorry. Yeah, this is a string method. What am I doing? Yeah. So I'm going to say if type of, let's say a not equals to int, or let's say type of b not equals to int. I think this should be okay. Let's run this. Then you raise a type error. So this is the type error in your function. So when you write functions, basically, let's say if they are expecting a certain type of an argument, then you can always raise an exception yourself by doing this. So this essentially will terminate the program at that point. You can also return the program. You can also return something. You can say return none, or you can raise an exception. It's completely optional. I mean, it's up to your code logic, whatever you want to do in that particular case. But what I wanted to show you was how you can raise some error. All right, if you guys want to try this out, you can try this out.
If let's say the func is called from a block, which is again in an try catch block or try except block, then would this raise in func cause function with the program termination, or would it be caught at the higher level?
So if once again, it depends. So this, at this point of time, this function is going to raise a type error if something doesn't match. So think about this, for example, the example we showed here, open function, right? Open function has a logic to throw error. So it's like this. So if you are now calling that other function, func, and if you do not put it inside a try catch, then, and if the func throws an error, then essentially your program will terminate at that point. So replace func, for example, with open here. It's the exact same behavior.
Got it.
Does it make sense?
Yeah. So essentially what we are saying is raise will not always terminate the program. It will, if it is the exception is not caught, then it will terminate.
The raise will always try to terminate the program. But if the higher block, wherever you are calling it, if you're already catching for the exceptions, then you may or may not terminate the program based on your choice.
Okay.
Yeah. There is another important tool that you can use to debug your programs, or to actually put in your programs to test certain conditions. Okay, what I did here was here I explicitly check the conditions in this way. You also have this statement called assert statement, right? Whenever you are writing a program, and let's say you want to check some condition, whether some condition is true or not. Let's say some physical quantity, for example mass, cannot be negative. If you want to ever, while doing the code, you want to check somewhere in between, you can always put an assert statement. Assert statement is a very simple way of like raising exceptions and terminating the program. Let me show you what assert statement does. The way assert works is that you write assert and some condition. Okay, so what you will do is you write assert and say 5 is greater than 4. Sorry, 5 is greater than 4. So here it's okay. But in the next case, you write 5 is greater than 5. Then you will say assertion error. And you can also print stuff here. You can put a comma and then put something here. Some error occurred. So notice your program can throw an assertion error. So people use this a lot as well. But specifically in the case of when you want to check some arguments, or when you want to check some condition at different points in your program to make sure that the things are in order. So suppose you are writing a function which is going to deal with some kind of physical quantities. And let's say at any point of time, those physical quantities can't be negative. So, and your program is throwing bugs, it's throwing errors, and you want to find out what's happening. So essentially what you can do is you have some function, some lines of code are getting executed, then some variables are there, let's say x and y, something like that. At some point of time, you can just write assert x is less than 0 and can't be negative. So essentially in this case, assert is going to check this condition in this point in the program. And if this condition matches, then an assertion error is going to be thrown. And with a message that something can't be negative. So you can use assert as well. Let's try this in the program.
Can I ask you a question?
Yes.
With this function definition, so if I try 5 and 4, it gives me a error. So instead of or, I put and it works. So it's not
Yeah.
I think it's
Yeah, my mistake. I'm using not incorrectly. So I'm writing
is not right.
yeah, this should be like this, or I should put not and then equals
okay.
equals, one of the two. Yeah. So that was my mistake. Yeah. So you can also define another function. Let's define a function called func1, and this takes a, b, and now you check something like assert. This probably is not a good example. Okay, let's just say c equals to a plus b, and then you carry on to do some work with c. Suppose you say, actually let's define a better function. Say area, and area takes a radius. And suppose you want to calculate the area, so you say return 3.14 multiplied by radius to the power 2. Something like that. And you're doing a whole bunch of stuff in between, suppose. And so at some point of time, you can just write something here that assert r is greater than 0. And if this condition doesn't match, then you can just write radius cannot be negative. Whatever your program is, let's say at some point of time in your program, you might be assuming that you have a active connection to the database, but the connection is not present, let's say for whatever reason, then you can assert that thing. So let's call this area function, and then let's say you supply -1 to it, then it should throw a type error. And my mistake, this is throwing a type error first. Let's comment this out. So you get assertion error, and with the assertion error, you get a message that radius cannot be negative. So this can be a good testing tool. So this is a good testing tool. So people use it for testing some kind of invariance in the program.
So if you're using assert, then I'm assuming Python has some testing framework, or is that only specific for their web apps or frameworks like Flask or Django?
So this assert is a statement. I mean, what you're referring to, I think, is the unit testing framework. There are more things in the unit testing framework to like assert not and all that. But this assert is given as a language functionality. You can use it wherever you want.
Oh, so you don't need to do it. Oh, so there is a testing framework, and it can be used outside of it. I mean, I guess you're doing
you can
it now.
use outside of it. I have not imported anything here.
Right.
This is just natively running from the language. But there is more stuff in unit test module that probably we'll cover in the last session. So we'll see there.
So, Himanshu, this may not be, I don't know if this will be related or not, but once in a while I've seen like, editor providing some functionality to kind of, debug like step by step, including the values of the variables also shown,
right?
Kind of, get you a feel of where it is going wrong, something like that. Yeah.
Right. So you can always debug, right? So for example, of course you can debug your code as well. So let's say you are debugging your code. No, so there are a couple of differences. So you can debug this, and let's say you have a breakpoint here. Your program will stop at this point of time, and you can notice that the R is -1 right now. Right. So these are the name of the variables. But see, when you're debugging, you are going to provide some kind of input which which will already be good. You may not have thought of the possible bad input that might put your program in a bad situation.
Correct.
Right.
Correct.
So in a automation testing environment, or even a real life environment, when you assume, right, when you're in the middle of a program and you're going to assume that, okay, certain conditions are true, and based on that, I'm writing the next operation. But what if those certain conditions are not true? So you can put an assert there to test those out. That in the vast set of test cases, if this condition is not true.
Okay.
Yeah.
That second parameter is required for assert with a string.
You don't have to put it. If you don't put it, then it will just throw an assertion error. But if you want to put some more information, then you can put a string, yeah, as a second. You can call it whatever argument here. So if, let's say, you write assert 0 is greater than 1, then assert 0 is greater than 1, then this will just print assertion error. And then if you put a string, then you say cannot be possible. Then it will essentially put the cannot be possible as well. So you can, some debugging information you can put here. So this is the part on the error handling. We're going to touch this again when we talk about classes, because I think it's important to write your own exceptions and use them. So basically, when we talk about classes and object-oriented programming, I'll create few exceptions and we'll use those. And it will require some more understanding of how we do things in Python, something like function overloading, operator overloading, before we actually start creating our own exceptions.